Okay, hello, this is one of the virtual lab I was talking about. When you open it, it looks like what you are seeing on my screen here. Some features there, and you can actually zoom it in or out to make it larger or bigger for you to see what is there. You can actually rotate it, and when you click the assistant here, a robot here, you can read the instruction. Like it said, click next to see the reset of these instructions. When you click the next, the instruction appear here. Actually, when you click this small yellow arrow, it pop up all the instruction and what you need to read to carry out the experiment based on the one you choose. This particular one I choose is about titrating a strong acid against a strong base. Okay, so I will let you in to see how this works. Let's see. Okay, yeah, we got it. So the experiment title is determination of molar concentration of hydrochloric acid, HCl. And in this particular experiment, we are going to, these are the goals that will gain the knowledge of how acids and bases will react if their formulas are known. Another one is understand the titration concept. Another one is standardize and accurate solutions of sodium hydroxide to be used as the titrant. Take note of this. The titrant here is sodium hydroxide. Then calculate the concentration of an unknown strong acid given the amount of base necessary to titrate it. And then another goal or objective again is use titration data or titration curve to calculate reaction quantity such as the concentration of the substance being titrated, and then calculate and compare the molar concentrations of a known acid solution obtained by the results of the titration curve. Alright, so these are the learning goal for this particular experiment. Let's see how it goes. And at every point you will see the instruction pop up on your screen. If you don't know what to do, the assist will actually give you what to do when you click on it. Okay, so we'll click next and then we go. All right, stage 1 or step 1, standardization of sodium hydroxide solution. And of course, you know, in the lab we have all the laboratory equipment or the lab apparatus you can see here, just like you see in the normal lab. Then again, you remember in work sometimes they will ask you a question to see what are precautions taken while you are carrying out your experiment. Some of the things here are some of the precautions. 1, make sure that the bottle is dry and clean. Otherwise, you have to wash it twice with water and then alcohol and leave it to dry. These are precautions taken when you are doing this experiment. Awesome, right? Great. Okay, here I have my deionized water. I have my beaker, my conical flask, the funnel, the pipette, and my 1 molar solution of sodium hydroxide, my pH, amber bottle 500 ml, and then the hydrochloric acid. Then I have my cylinder, the measuring cylinder here, then the graduated cylinder here, and of course here you see the retort stand and the burette already fixed there. Then again I have the bulb pipette, and of course my waste bin. Anything I do, and if I want to discard it, I put them in the waste bin. Of course, like I said, you can increase or reduce your lab actually. So what is the first instruction? Even if I don't know, click on the assist the robot here and it will give you. Step 2, add 450 ml of deionized water to the amber bottle using a graduated cylinder and the funnel. See the funnel? I put the funnel on the graduated cylinder and I'm to add 450 ml of deionized water. This is my water. I'm sure you'll be able to see it very well. Amber bottle. Sorry. You add deionized water to the amber glass bottle using a graduated measuring cylinder. No. Yeah. 4 ml of deionized water in this graduated cylinder. Okay. Then I'm going to add it to the amber bottle. These are amber bottle here. Remove the cover. Okay. Place the funnel on it. Then I'll take my 450 ml of water and then pour in the amber bottle. That is done. Okay. Now you bring in a 50 ml graduated measuring cylinder and make sure that the measuring cylinder is dry and clean. Otherwise you have to wash it twice with water and then rinse it with alcohol. Instructions given. Okay. What next do I do? The next step is use the measuring cylinder to obtain 50 ml of 1 sodium hydroxide and pour it into the clean 500 ml amber glass bottle. 500 ml amber glass bottle. What do I do it? I have to measure 50 ml of, first of all, take the funnel on it, and then what's the next? 50 ml of sodium hydroxide. Remove the funnel. Again, this is also a precaution taken. Eye protection must be worn at all times. I can record these two as my precaution. And again, sodium hydroxide is caustic and should not come in contact with your skin or clothing. Wear gloves when handling these chemicals. These are precautions. I'll pick my sodium hydroxide and pour it. How many ml? How many ml again? I'll go back to my instruction. 50 ml. Okay. All right. I got it. Okay, I need my it should be poured into the 500 ml amber bottle. All right, now I got it. 50 ml of 1 molar concentration of sodium hydroxide and pour it into the amber bottle. I'll cover my sodium hydroxide, then open the amber the funnel. This is the 50 ml. I'll pour the 50 ml in it. Right? Good. Then next thing is, make sure that the bottle cap is tightly closed and shake it to make certain the solution is completely mixed. Where's the bottle? Then I have to shake it, shake it, shake it, shake it, shake the bottle to make sure it's tightly closed. The bottle now contains a sodium hydroxide approximately 0.1 mole and must be standard. This is a standard solution of sodium hydroxide. Good. Start to set up the titration apparatus by attaching the clamp to the retor stand to hold the burette. Already it is set here. Already it is set. So I have made a standard solution of sodium hydroxide here in this bottle. That is what I'm going to use against hydrochloric acid. So my beaker is ready. As you can see, it's even prompt me to know what the next thing to do. But then I have to follow the step. Place 250 ml beaker below the burette. This is the burette. This is 250 ml beaker. Place it below it. Leave enough room for glasswares below these are precautions needed to take to perform the experiment. Okay, then I've done that. What next? Fill the burette with 50 ml of standardized sodium hydroxide using the funnel. Okay, fill the burette. My burette is here. Of course, I have to put the funnel, and this is the standardized sodium hydroxide. Make sure there are no air bubble in the tip of the burette. What do I do? Maybe you raise the funnel up and place it back again. That could erase any air bubble in the burette. Okay, and these are precautions too to be recorded while the experiment is going on. Let's continue. Pour and pour. All right, remember to cover your bottle. All right, awesome. The next thing to do, next step, let the liquid flow into the beaker 5 ml to remove air bubbles. Then fill the burette with, let the liquid flow first. Let me let the liquid flow first. You click on it, 5 ml. This instruction. Then fill the burette with 5 ml of standardized this, which means since I let 5 ml out, let me let 5 ml in again. All right. Remember precautions. Take the cover. Great. What do I do next? The next step, remove the beaker and add a dry clean 250 ml conical flask. I remove the beaker and do what? Add 250 and add a dry 250 ml conical flask. Okay, I want to see this in very well. Okay, what do I do? The next step is transfer 10 ml of standardized HCl solution into the 250 ml flask using the ball pipette. This is a ball pipette. Where is my ball pipette? watch that you see the volume. How many? 10 mil. 10. Okay, I have 10 mil. Eye protection must be worn at all time. Precaution: hydrochloric acid is caustic and should not come in contact with your skin. These are precautions. Have I gotten my 10 mil from here? Alright. Well, the next thing, got in the 10 mil. Add it to the conical flask. Conical flask. Great. And then I think I'll bring my conical flask here. Yep. My bottle is not covered yet. And that is done already. Then the next thing is, I've done this already. What is this again? I've done this already. I've done this. What's this? You see what happened? I am supposed to rinse this my ball pipette with this my waste bin. Raise it. I didn't do that. That's why the experiment could not proceed. So I have to do that. I rinse it and keep it. Then the next instructions on the next step. You see, add 2 drops of phenolphthalein indicator solution. Where's the phenolphthalein? I think, yep, phenolphthalein here. 2 drop of phenolphthalein indicator to the using the, yep, is it. I push it inside, pick it, and then 2 drop, 2. That's okay. Alright, so the next thing is I have to cover my phenolphthalein bottle. Great. You see, the next thing is 2 drops of, I've done that. I need to rinse this. Great. The flask should appear colorless. Is it? Yes. The question here, what is the role of phenolphthalein in this titration? A, to bind the analyte to form a product, or to show when the reaction has reached or passed the end point. Of course, you know, if this is the answer, or if this is not, you see that it will show red. You see, this is the answer, of course. Record the initial volume of sodium hydroxide in the burette before you begin the titration. Okay, so the molarity of sodium hydroxide could be calculated using the following equation. Volume of hydrochloric acid equal to molarity times V of sodium hydroxide. Okay, this is well taken note of. I think if I zoom in, I should be able to see it also. Should be able to see it. Okay, all right. So I'll bring in here. Let the liquid flow into the flask by clicking on the tab of the burette. The solution will initially turn pink by the addition of sodium hydroxide drop and then fade back to colorless when swilled. Record the final volume of the sodium hydroxide in the burette, then when the solution in the flask remained faint pink for about 10 seconds. These are instructions you need to follow. Here, where is it? I think it's somewhere here. Yep. just like we could have normal in a normal remember by the left of the screen you see the calculation where you get your calculation from, and keep your eye on this. Then when it's done you end the titration. You notice a color change. Keep on shaking it. This virtual lab. No color change. Alright. Oh, I didn't notice it. Wow. There should be a noticeable color change. Or do I miss anything? No result is also a result. Remember, if I had made a mistake in this, no result is also a result as far as science is concerned. All right. I haven't noticed anything yet. All right, let me end it here so I can use this to explain other things. You have seen that you can actually use this virtual lab to carry out titrations, test for radicals, and test for any salt in chemistry and in physics as well. I think I'll show you that of physics too. The experiment has not ended yet. "18 seconds. You're supposed to stop at 10 seconds actually. Reading it 8 seconds. So you now impute your, the same way we do. You do the first one 10 seconds, second one 10 seconds, and you record initial volume of the base, second titration, third ones like that. These are where you enter. Maybe is 18. Then I don't know. Enter value is incorrect. Maybe it's 25. I don't know, because I have not taken notes to actually calculate it. The second initial one like that. So I'm just trying to show you how then you enter your result, you submit. It will take you to the next one, but because this is not correct, it's not going to allow me to go to the next one. But I've been able to show you that you can actually use virtual lab for your titration. Okay, the reading is 18. Okay, let me see. Then why do I get it wrong? 18.00. Okay, then I did not do the second one. Maybe the second one is 17.00. By assumption, maybe the third one is 19.00. 19.00. Sorry. The volume of the final volume. So you just end, continue, and then you fill it up. You're good to go. Okay. Let me show you that of test for other thing. Just hold on.